So is this how it ends? This is supposed to be the last lecture, and so we usually finish off on terrestrial biomes. It's a pretty lengthy lecture. We're not actually going to go through everything. I'm going to kind of hit on the big points and all that. But yeah, today I gotta say this is how it ends. So I've been filming lectures for about 2 hours now, just kind of going, rattling them off and all that. And after this, I'm going to gather all my plants. I'm going to move my research experiment to my house, my garage. I'm going to be doing research out of my garage. I have plants that I was trying to start a garden with here, and I'm going to see if I can keep them alive in the little sunlight I get. Today, the number of cases passed 400,000 of coronavirus. Today, Donald Trump says that by Easter it'll all be over. Who knows? You know. I don't. Think about the gift that you have right now, just knowledge. Or think about the innocence that I had. I didn't know what was going to happen. I don't know what's going to happen next. Here's what I do know. Tonight, I'm doing these lectures. Tomorrow, I'll be off campus, and I don't even know if I'm going to be in this room again for a very long time. We don't know. We don't know what's going to happen. But I will tell you a few things. The study of ecology, the study of evolution, the study of life on Earth is a big, fat lot of we don't know what's going to happen next. Except for one fact. Earth abides. Life abides. The dude abides. No matter what's going to happen, there will be some microbe out there that's going to make it. There'll be some biome that's relatively unaffected. If you want to see the different tragedies that have been visited upon this Earth, when I tell you to, just switch off this lecture and go watch Our Planet with David Attenborough. This is going to be a long lecture. Pitter patter. Let's get at her. Terrestrial biomes. Land. We're going to cover a few things. Hadley cells. I want you to draw Hadley cells on a global map. Identify high pressure and low pressure latitudes on a map. Relate seasonal variation to planetary tilt. Define rain shadow. Define lake effect. Moderating effects of bodies of water on temperature. For those of you watching from Hawaii, you get it. Draw and label the Earth's major biomes on a map. To an extent. I just want you to know where they are. For each biome, temperature, precipitation, and seasonal variation. I'm going to do more drawing and less, notes. So just follow along, draw along, okay? Global ecology is where we're finishing up. We've done populations, organisms, communities, ecosystems, landscapes, we skipped, but global ecology, study and function of organisms across the whole beautiful biosphere. They're not all the same. Those are the different biomes. We'll come back to that. But why? Why are the different biomes where they are? Well, it's largely determined by solar radiation. So where things live on Earth all depends on where the sun is relative to that thing and the planet's movement through space. So solar radiation, take a globe. It's going to be highest here at the equator. And solar radiation lowest here at the poles. So the lower angles mean most intense, least intense. So the tropics are going to get the most solar radiation. So we remember the most solar radiation means the most primary productivity. And the poles are getting the least solar radiation, so the least primary productivity, so you can bet the least of every other type of, at least primary productivity means less consumers, less tertiary consumers and whatnot. And the seasonal variation is greatest in the poles. What's seasonal variation? Seasonal variation, but the movement of the Earth's a little bit tilted, and as it moves around the sun, so here, my fists are closest to the pencil, moving around the sun here. Now my wrist is most close. So that's the movement of the Earth around the sun. It's tilted. And what angle is closest really just depends on what part of its orbit it's in. So if it's directly overhead, though, if the sun is directly overhead, blind, but it doesn't really matter since he's letting all the light off, you know. Okay, the sun is going to radiate down. And that's going to warm up the ground. So the ground's going to get nice and warm, which is going to cause evaporation. As the ground warms up, hot air is going to be rising. As that hot air rises, it expands. Because Earth is a sphere, the farther away you go from the surface of the sphere, the more volume there is available. So as it expands, though, it's going to cool. And as air cools, it sinks. And it's going to replace the hot air. Because if air moves, if air goes up, it's going to need to be replaced from the air coming from somewhere else. And this is a convection cell. Convection cell. You can see this if you take a pot, a big pot, and put it on a small burner. You see the hot water will rise in the center, go to the outside where the burner isn't, fall down, and then replace it. Just kind of make these convection cells. Same thing happens on Earth. So we have this, though. If this is the equator, where the sun is most directly overhead, these would be 30 degrees north and 30 degrees south. What's going to happen is the air is going to ascend there at the equator, and as it ascends, it cools. As it cools, it can hold less water. As it can hold less water, it rains. So then the warm air is going to rise and flow to the north, to the south, and it's going to cool. As it cools, it becomes dense. Remember, cold things are dense. As it's dense, it's going to descend. As it descends, it picks up moisture. So now you have dry air coming down at 30 degrees north and south. Fun fact, it started out cool, but what happens when you take a gas and you compress it? It's hot. You have now cold air descending, becoming warmer, and becoming more able to pick up moisture. This hot, dry air descending upon 30 degrees north and south. And no surprise, that's where we find our deserts, 30 degrees north and south, where we find our deserts. Now, of course, the Earth isn't just 30 degrees. What happens is the cold air is actually going to radiate out, and it actually makes another cell here. And there's actually a third cell up here, made of much colder air. Over at 60 degrees. So this is going to be there are different cells. This is actually, when you're talking about the Earth, this is called a Hadley cell. It's called a feral cell. And this is unoriginally called a polar cell. Discovered by Dr. Polar. No! Anyway, what's going to happen here is around here, it's the abundant precipitation in all seasons near the equator. You have wet summers and dry winters as you move further from that, but close to 30 degrees, it's dry at all seasons, and a wet winter, dry summer. Now, we have wet winters and dry summers. Subpolar low is ample precipitation in all seasons. Not quite where we are, but north of us, yes. And polar high, all this high pressure at the poles, is actually sparse precipitation in all seasons. It's almost a desert at the poles. It doesn't actually rain or snow that much. It snows more in Washington, D.C. than Antarctica. It's just the snow stays longer, blows more in Antarctica. But this is the reason we have different climates. Is it's all due to the sun above the equator. And the seasonality is just due to the rotation of the Earth around the sun. And what side is facing it. Since the Earth is at 23.5, a tilt in the day length is going to lead to a difference in temperatures. In the summer, the 23.5 degrees is perpendicular. Sorry, in the summer, the sun is perpendicular to the Tropic of Cancer. So these cells move. In summer, but you get the idea. So that's going to start growing. That's going to move the precipitation, which is why there's those dry summers or wet summers, because they're moving according to the variation during the year. And the equinox is perpendicular to the equator, which is twice per year, which is why you get that abundant precipitation in all seasons. All right, that's the globe. Let's zoom in, shall we? And let's just, you know what, fork it. We're going to stick in forks, okay? Forks. Here we've got the majestic Olympic Peninsula. Kitsap Peninsula. What remains of Seattle. I don't know, Aberdeen. I think there's another bay there. There you go. Okay, looks like a leaf. Anyway, we are, well, I am here. We've got some other features here, though. Proximity to water affects the temperature. If you watch the temperature, there you go. Spokane's over there. Okay, so the closer we are to water, the temperature doesn't change that much. So proximity to water means in Aberdeen, there's less temperature fluctuation than in Olympia. In Olympia, there's still water, so there's less temperature fluctuation than there is in Spokane. We also know more water evaporates over water than land because there's more water over water because it's water. Anyway, that's going to change things out too, though. We have a lake effect out east. Let's ignore most of this because we're not out east. But if you are, so this is when winter decides to move the lake just to the east a bit. The wind will go over the water, and the water temperature will warm up the wind. And that will put more precipitation into the air. But then the wind goes over the land, it cools down, it loses that water in the form of snow. But when the water temperature is cooler than the land, then you actually get clear skies. So places like Buffalo, New York get this during the winter, but then during the summer they actually get a lot warm, clear skies. Very pleasant. Here we go. This is more fun. We got some other stuff going on here. We've got really nice green mountains. Oh, Olympics. Tiny hills. We'll cover the tiny hills. And then, big mountains here too. Cascades. All right. You guys might know that Forks is where vampires live because it's always cloudy in Forks. And that's because out here, it's not mountains. It's lots of water, waves, such. There you go. Nice. So air moving from the water to the land is going to have to go up and over the mountains. As the air flows from the water to the land, it's going to start cooling, and it really starts cooling when it has to ascend and climb the mountains. If you doubt me, just climb the Hoh Trail and tell me if it's cooler at the top of the Hoh Trail in Mount Olympus than it is at the base of the Hoh Trail near Forks. It is. It's cooler. I haven't tried yet. But the air cools, the air loses moisture, and it's going to dump the water here. Now, Paulsbo, where my parents live, what happens is the air will descend, and it'll come down. It'll be drier on the other side, on the leeward side of the mountains. You get less rain in Paulsbo than you do in Forks. You get less rain in Olympia than you do in Aberdeen, too, because of these small capital forests as well. There's something called the coastal range is still around here. There's smaller forests, there's smaller mountains, but it's just enough that we get less rain than Aberdeen. But if you want real less rain, make that water cross the Cascades as well as the Olympics, and Spokane's practically a desert. So you get heavy precipitation on the windward side, and much less precipitation on the leeward side. Now, of course, you still have water. A lot of systems actually move from the south, which is why we get plenty here. But if wind systems are moving from the south, you also have a place here called squim. And when the rain systems are coming from the south, they lose their moisture. Squim is actually very dry. It has plenty of lavender. Beautiful place, beautiful place. Here's the map for that. So the Olympic National Park rain shadow and all, you can see the purple having much more rain. Places like there's Port Angeles, Port Townsend. Squim is, if you can see the mouse, it's right here. You can see the mouse pretty well. You can't see the mouse on the screen. Oh well. Squim, look it up. Anacortes and the islands also have less moisture. All right. So that's the abiotic factors are going to affect the biome because they're affecting what plants can grow there. A desert can have warm temperatures or cold temperatures. You can have cold deserts, but it's always low precipitation. Tropical forests, they have a range of precipitation but high temperatures. There's overlap between these biomes too due to other factors. So I pointed out something called Bloomington on there. So Bloomington is where I lived before I came to the Pacific Northwest. It's Bloomington, Illinois. You notice it's right at the triple point between temperate broadleaf, northern coniferous, and temperate grassland. Longer winters, it'll become more coniferous. More moist summers and less fire and less agriculture, it'll become broadleaf forests. We actually saw maples invading a lot of the forests there, but fire turns it into a temperate grassland. Bloomington, Illinois used to be a grassland when the Native Americans kept burning the place. Started being more of a maple area when we stopped. Hickory too, actually. So the overlap is due to other factors. Lacey and Olympia are between the temperate broadleaf and northern coniferous forests. A little bit cooler, it'll become more coniferous. A little bit warmer, more broadleaf. So there are open spaces there. Debate that yourself. And here's a big biome map. Deserts, 30 degrees north and south. Tropical forests, right along the equator. You move away from it, you get things like tundra at the far poles, low precipitation, cold temperatures. Here's the deal. Precipitation and temperature rule it all. You can look at any one of these biomes and look at the temperature and the precipitation. I'm going to kind of frap through them, but here's the thing. I'm tired. End of the semester. Well, for you. Plague epidemic, and it's 9 at night right now for me. David Attenborough does this better. I mean, he's the man. David Attenborough covers this so much better. Just, if you can get a hold of it, watch Planet Earth. There's a good chance that I just skipped the last lecture and just did Planet Earth anyway. David Attenborough's the man. He does this so much better. I just recommend watching the whole series in your bunker with your family, and or maybe it's all good by now. Either way, it's a great series, and he covers every single biome better than I ever could. I'm going to cover temperature, precipitation, but I'm going to kind of rapid fire them because otherwise this actually does come out to about 2 or 3 lectures, and you can compare it to your car because I am barely getting started. Let's do this. All right. Tropical rainforest. Don't worry about the graphs. You'll learn them in field ecology. Tropical rainforest, high precipitation, no dry period, temperature constant, temperature always above freezing. Very little variation in daylight. Desert, there's long dry periods. Mean minimum temperature may or may not be freezing during some months of the year. It may or may not freeze over. Temperatures have a deserts have a wide range of temperatures. They may have a moist period, but the drought would coincide with the growing season. So you might get a moist period, and at that moist period, it's too cold to grow. Water is available as snow, but that snow sublimates and just kind of goes up into the atmosphere and doesn't provide water. That's a desert. Very strong variation in temperature between night and day because there is so little moisture to kind of keep that constant. Some adaptations of the deserts, being drought resistant, of course. You see the mammals that are low water uptake. Remember the kidneys that mammals have that are going to help them survive in desert environments. Temperate grassland. There is seasonality, so there's a cold season and a warm season. Winters are usually cold and dry. Summers are usually hot and wet. So the growing season can be very intense. Temperatures vary seasonally, but they're not extreme variations. The daylight will vary, and this rainfall is strongly seasonal during the summer especially. A lot of the plants here are fire tolerant because those fires can bring, those storms can bring fire. The dominant animals by biomass are insects, and also by ecosystem function. Temperate forests. Temperate forests they have a freezing season. They have moderate variation in temperature. They often have low seasonal variation in precipitation, so there isn't a dry season, except for temperate coniferous forests such as here in Washington, where you have a seasonal drought right in the middle of the growing season. That causes us to have a coniferous forest as opposed to a broadleaf forest, because broadleaves aren't as drought resistant. Remember, the gymnosperms are more drought resistant than the angiosperms. All right, other cool stuff. No, we're not going to come to the other cool stuff. Okay, fine. Tropical dry forest. There's a long dry season during the growing season, and they can have a very strong wet season, like in Mumbai, India, where the precipitation just goes way up to 1808 millimeters during some months. It gets pretty crazy. So deciduous trees can have very old soils. That's just a cool season one because that's kind of like if here, but way hotter. Anyway, try to keep it short. Managed to keep it short, but mainly by taking out the whole wow factor that I really enjoy sharing things with you, but it's really hard to share things with a computer screen. Guys, I miss you. I've been missing you only for 2 weeks, but by the time you see this lecture, I've been missing you for months. I've probably been quarantined with my kids for quite a while. They're doing all right so far, but it's only been a couple weeks, so. Yep. This isn't the fun I wanted to have. This is normally where we'd end with a really cool, tying everything together and see the sparks light up in your eyes as you realize, holy crap, there's a lot in the final. There'll be student evaluations. I mean, honestly, I want to hear back how you think this whole thing worked out. I did YouTube because it's the lowest common denominator, and I didn't know that at the time when I started the YouTube, we'd eventually go all different time zones. Now we've got people in Guam, Hawaii, and people are leaving campus this week. So we're all going to the 4 corners of the earth. I want to hear about the biome you're in. I really do. Just put it in the comments section of the forum. That'd be great. I wish you were in my biome. I wish you were here. I wish we were on campus. And we did the best we could. YouTube was a low common denominator. You can watch it anytime. You said, hey, we can pause it. That's good. You guys gave me a lot of feedback. You really helped me grow through this. I hope you grew through this. And I hope you became more resilient through this. This is where I tell you I've been encouraged by you this semester, but this semester is barely halfway over. I'm sure I will be encouraged by you guys. I'm sure I will be encouraged by your strength through adversity. I miss you, though. I miss you a lot, and I want to see you back next semester. Warn me, but, high fives, handshakes. Let's bring it all back. I'm not saying no hugs, but warn me. I'm looking forward to being within 6 feet of another human being again. So it's been a good semester. See you later. Bye.